Emily usually bees a little early on all that.
Yeah. But they're doing a lot of construction out from the direction she's coming. That'll mess with people for the rest of the school year until we wrap up. There's gonna be people messed up because of that traffic, I'm sure of it.
Yeah.
You keep like changing the patterns and blocking stuff and just making life difficult for everyone, you know. It'll be nice when it's done, but in the meantime, it's pretty ridiculous, so.
That won't go under what? That is. That it takes skill, you know.
You get it?
So Xander was supposed to be in the junior lab class?
No. Mm-mm.
Wait, that's what my brother said. He said he had a Spanish class.
Well, I don't know if he was supposed to be in junior, but he's been in senior all year, so.
Oh yeah.
Works for him. It never works. When he does like Spanish. Next year, there's Spanish too, as well. She's doing Spanish 1 and Spanish 2. So. There's time for Spanish next year if you wanna do Spanish. Senora's got it all together. Ready to roll.
Chemical one. That looks like a good picture.
Yeah.
Does AI design it for you?
No, PowerPoint just found that one for me. There, you can, I don't know, do you ever play around in PowerPoint? Have you used it much? You can,
I don't know.
I mean, if you put a slide together in PowerPoint, you can do a thing where you just say, like, you can hit, there's a little tab that says designer, and it'll offer suggestions. And sometimes it's pretty good, like, it'll give you something like this that makes sense, and other times it clearly doesn't know what you're trying to do. But it uses whatever words you've typed in on the screen to pick a design. Sometimes they're not conducive to having a lot of information on the slide, and so you kind of have to fuss around. But I've got next year's syllabus done. I've got next year's preface done. I've got about half of Q1 complete. So
For next year?
Because I've done it before, so there's just like a little catching up to do to make sure that it's kind of in the same exact format. Because last time I did it.
Are there
was in full.
11 lessons for you?
I think there are 9 next year, 9 or 10.
I think Q1 this year is the biggest lesson.
Yeah, Q1. It just had to do with the way the calendar worked, like more than anything. I'll show you.
Any glasses. Los alumnos en mi clase. ¿Qué significa sus alumnos?
For next year?
Basically, so.
This is next year's. There you go. So there's Q1. Q2 is really short.
Q2, yeah.
Well, because there's a break in the middle. Q3, it's going to be a little weird in Q4 because of the way the county, first off, Q3, they didn't really build in they kind of built in a fall break or winter break this year in the public school this next coming year, but it's it's weird and it's just a teacher day. And since there are a lot of lessons for chemistry, there's a lot to cover. I opted not to take that one off. We could have done it as we could have done it as an online, but anybody can always do that. But this is gonna be weird because it's like we have a lesson, a break, a lesson, a break.
Lesson, lesson.
Yeah, and I don't like that. I like to do 2 weeks together or just 1 week off. I don't like to do a lesson. And I thought, well, maybe I could make this online and give y'all 3 weeks out. But the problem with that is that that's a really good lab. Hey,
Hello.
welcome back.
We've achieved American, we got a truck.
All right. Who's driving said truck, mom or dad?
Yeah.
Dad.
Electric truck though.
Wow. And what did you get, a Rivian or?
Yeah,
we can.
we were trying to open the
Nice.
tunnel that had our bags in it. It was kind of.
Oh, that's hilarious.
Yeah.
That is funny. Excellent. Well, Scotsman in a Rivian, way to go. Nice. I was just showing him this is showing Eunice, this is next year's schedule so far.
Okay.
So I've gotten all that set. I already have it all done. Next year's final project is a fun one. It's I need to change that date. See, I keep finding stuff. That's why it matters. Got to change all the dates on this project still, but yeah. Hey, hey, how's it going? How are y'all?
Good thing.
Hello.
This is next year. We were just peeking real quick.
A very long time, I know, right? So long. Emma's usually the first one here.
Yeah.
And
Oh, wait, she isn't coming this week.
Oh.
I think she's not coming. I remember her mom saying something about they have tech for theater. So, yeah, that's what it was. I knew yeah, it was like, I think everybody's gonna be here. No, I'm not, I'm lying. So this is everybody. Good morning, everybody. How is everybody? Yes, awesome. So we've only got today and 2 more lessons and then that's it, our final after
I
that.
only have 2 more gymnastics practices to my next meet.
Where are you at, Jim?
Jump CMT.
Okay, yeah. What level were you at?
It's not like really levels. I guess I'm intermediate.
Okay, so is it a USAG meet or is it?
It's just trampoline.
Yeah, you're doing tramp, that's right, you're doing tramp, not, yeah, okay, yeah, that's right. Very
If I
cool.
were to calculate myself, I'd be, beginner.
Did you get contacts?
Yeah.
Awesome, how do you like them?
I've had it for a while, but.
Yeah, I
just
thought
recently
you
broke my
contacts.
glasses.
How do you like them? Do you like it better? I hate wearing my glasses. Cause I need such magnification because I'm so nearsighted.
So thick.
That like, yeah, well, the lens
you
is
have
thick and then,
contacts?
oh yeah, and then everything around them, I have like no peripheral, right? So when I walk down the stairs, I have to walk looking straight down like this or I'm gonna fall because like the weird thing is, like, I think I told y'all when we did lenses, but like for everything to be focused, it makes it small. So like, there's a size difference in the stairs when I'm walking, like from what I don't really see. It's weird. It's really weird. Well, I love them. I may one day decide to get them zapped. Yeah, it's kind of stuck. It's all right. We'll wake it up here. Maybe. All right. So I got your email and I fixed it this morning. I think that was, it saved the same file twice despite me trying to save something else. So your final exam study guides are loaded. I just, because I just typed it 2 seconds ago.
Okay.
Load.
Brownie point.
Oh, you have one? What is it?
Develop that first. It's supposed to be.
Ah.
Brownie point on the test as well.
Oh. Well,
I
yeah,
can't
found him.
spell, so I have trouble finding them.
Oh, I do, yeah. All right, so located in your I just typed that this morning for like 5 seconds before you walked in the door. Located in your resources folder. So Darcy already found them, apparently.
I did. I'm a computer genius.
Yep, so be sure to go into your Dropbox, right? Go into your resources folder and there's one that says midterms, and there's one that says junior lab rats, and you go in there and it's got 3 different options for you. It's got a link to Jeopardy. It's got
Jeopardy.
good. It's got an answer reveal, like the slideshows we do in class, where you have to click to make the little box disappear. And if you're using like Google Slides, that might not work.
Yeah.
So like if you open it, it depends on what program you open it in. If you open it in Google Slides, that might not work. If you open it in PowerPoint, it will work. And then the other one has all the answers already visible. So you can go through it and study it that way. Everything's on the page though, so you kind of can't like trick yourself. But anyway, there's a lot of options for studying. All right, well, let's do day. We've only got like 2 more lessons, so we're almost done. So the periodic table is a chart of chemical elements arranged in order of what? How are they arranged? All right, Carlos. Oh, wait, he had it. He's looking.
Arranging
Order of. Do you want to toss it to somebody? Very good. Okay, we'll give it. Atomic number is what we're looking for. So yeah. All right. Which is usually rows, so that elements with similar atomic structure and hence similar properties appear in vertical columns. So this has to do with the valence electron situation. Do you remember how in lab last week, or those that were here? I don't know if y'all did it on your own, but that's one you could totally do on your
We
own.
saw the video. I was unable to comment, but I did see it.
Okay, so
I commented for Darcy.
okay, good. All right. So the way our lab worked last week is we had here's a copy of it actually. So we had like a little diagram,
And then you.
right? And then we put the Skittles and the M&Ms and the various.
Of course, we mixed one with candy.
Yeah. So anyway, that has those valence electrons are what's involved with how certain elements interact with other elements. So if we go by number from left to right, just like how you read, right? Then the only thing that the way it works is it ends up lining up so that like these guys are similar, these guys are similar, these guys are similar. Like a great example is if you look over here, where's sodium? Somebody see sodium? Na, very good. So these make really good salts when combined with
Like
these guys. So especially chlorine is real good at, like you've heard of chlorine, you've heard of sodium chloride, right? That's table salt. Well, there's also potassium chloride, lithium chloride, right? Because they combine well just based kind of on their structure.
I can remember part of this song. It's like lithium, beryllium.
Yes, there's one where people have memorized the entire periodic
I
table.
only remember like the first row.
Yeah, and you're welcome to do that if you want. You don't really need to, because the point of the table is it's a tool. Like it's a tool for you to use, and memorizing it's, I guess maybe it familiarizes you with what's next to what, but in the long run it's better to understand how to use it than to memorize it. Yeah,
Like your shirt.
thank you. This is my periodic table shirt.
I have my friend has one that says sarcasm.
Yeah, I think Drew got me this one actually a while ago. All right, so who's this guy? Okay, Darcy, you want to go? Mendeleev. Okay, so Dmitry Mendeleev, and this is his name.
Dmitry, so he's Russian.
Yes, that's Cyrillic. That's Russian language, and that is his name in Cyrillic. So if he was gonna write his name, he'd write it like that,
I
right?
can read Russian a little bit because of the movie Tetris.
You can kind of see some similarities, like
There's an
Dmitry,
M and an E.
kind of like a D, maybe Dmitry. And then the last one is Mendeleev, right? And you can see the D's are the same, right?
And the E's are the same.
Yeah, and the E's are the same. So there are some great memes about Dmitry Mendeleev because a lot of the pictures of him, this is one of the friendlier pictures of him. He looks kind of terrifying. He looks like he's staring through your soul in a lot of pictures. So you may find funny Mendeleev memes about him staring through your soul. So he was Russian, born in Siberia. Now, what do we know about Siberia?
It's cold.
Yeah, it's real cold. It's far north. It's basically a tundra, right? Like it's like almost like a winter desert. Like, yeah. So he was the youngest of how many children do you think? What do you think, Louis?
4.
Huh? 4, 12, 6,
3.
something crazy like that. Let's see. Oop, where did that go? I don't know where it went. Where did that go away?
6.
Hold on. Oopsie.
Control delete.
Oh, why is that like that? Well, never mind. I'll look it up for you because it disappeared. That's fun. Uh-huh.
Was it 6?
I don't know. I will look.
Is it 3?
So this is his original periodic table. I'm gonna look up real quick because I don't know what happened to that one. How many siblings did Dmitry Mendeleev have?
It's like the youngest of one child.
I think it's like 13 or something crazy.
8.
He had 6.
Knew it.
Wait a minute, no.
No, he had 6.
They had 2. Anyway, I'll look it up for you during lab and make sure that we have it because, oh yeah, this is what I mean by pictures of him staring through your soul. See, there's a lot of things. He's kind of scary looking. He's like a demented Santa Claus. I don't know why, but I mean, really, he is.
Pick up some cash.
It's funny. It's like, what are we doing? Oh my gracious.
He's Mr. Grinch.
I don't see where the thing is. I have it, but I don't know where. Oh, 17. There it is. 17. Let me make sure I have that in here because that's weird. It should say 17. Yeah, that's not a brownie point. That's a screwy
It's a
thing.
big amount.
That's a goofy.
That's an entire brownie box.
Right on. And now we got it. All right. And he said, this is a good quote. I saw in a dream a table where go back.
No.
Where all the elements fell into place as required. Awakening, I immediately wrote it down on a piece of paper. Only in one place did a correction later seem necessary. So dude dreamed up the periodic table. Good for you. That's not a dream I'm ever gonna have. That's really impressive, right? All right. And that's what it looked like originally. So as you can tell, it's not quite the same thing, but the idea is there. So the modern periodic table is not the exact thing that Mendeleev came up with, but it's
better.
it's an improvement on his original idea. He got the ball rolling, which was important. All right, so here's this dude. If it'll go.
You look like you'd say hello.
Demented Santa Claus that he is. Yeah, he does. Her.
If you're into chemistry, you might have seen this table before, the periodic table of elements. Looks pretty complicated, doesn't it? Now we're going to meet the guy who came up with this table 150 years ago. He was a chemist, he was an inventor, and he was from Russia. His name was Dmitry Mendeleev. The periodic table is one of the most important tools in the world of chemistry.
Yep.
It shows the atomic properties of every element in our world in a format that's easy to read and remember. Like a lot of brilliant ideas in science, Mendeleev was helped by the hard work of scientists who came before him. As Isaac Newton put it, if I have seen further, it is by standing on the shoulders of giants. If Dmitry was alive today, he'd be around 185. He was born in 1834 in Siberia in Russia. Little Dmitry was the youngest of 13 or 14 children, no one's quite
And his Wikipedia says 17.
His
So.
mother came from a well-known family of local merchants.
Mm-hmm.
His father, Dmitry, was an educated man who was a teacher in a local school. But when Dmitry was still a little boy, his father went blind and had to give up working. This meant that to make ends meet, Maria had to go to work herself, and she started up the abandoned glass factory that belonged to her family. When Dmitry was 15, his mother took him out of the local school and travelled all the way across Russia from Siberia to Moscow to get him a better education. So it would have been a really big journey. When he finished school, Dmitry Mendeleev went back to school, but this time as a teacher and not a pupil. In his own time, he studied hard and he wrote a textbook called, you guessed it, Organic Chemistry. This won him a prize from the Petersburg Academy of Sciences. Now, when he was getting noticed in chemistry circles, I've just read Mendeleev's book, really good. Who's that guy, Mendeleev? and he was soon made a professor at St. Petersburg State University. And a year later, he became a doctor of science, and he was only 31. Looks like he's building up to something big. His personal life was not going quite so well. Around this time, he got married to Fiozza, a girl his sister knew, and she kind of pushed him into it. They did have 2 children, but they weren't very happy, and they stayed together for nearly 20 years. But by this time, he'd fallen madly in love with his niece's friend, Anna Popov. He was 47, she was 17. So you can imagine what her father thought, even if he was a very famous scientist. But they married, they were very happy, and they had 4 children. When he was a teacher at St. Petersburg University, he wrote a textbook for the students on his course. He was looking for a way to organize the chemical elements. Back then, they were usually grouped by their atomic weight or by their property, whether they were a metal or a gas.
That is atomic mass.
One morning in 1869,
Same.
after a
She
good
means
night's
mass.
sleep and with the taxi waiting to take him to the train station, Dmitri Mendeleev made a set of 63 cards, one for every element known at the time: silver, gold, zinc, copper, hydrogen, helium, oxygen, right up to 63. Like a fanatical card player, he spent 3 days organizing and rearranging his cards and completely forgot about his train journey. And then he was so tired he went to bed. He later said, "I saw in a dream a table where all the elements fell into place. The moment he woke up, he wrote it down." Brilliant French scientist Louis Pasteur said, "Fortune favors the prepared mind," and his life's work and the work of others had made him ready for this moment. Dmitri Mendeleev remained involved in science until his death in 1907. He was given lots of awards, 2 from the Royal Society in London and from Oxford and Cambridge. There's a metro station in Moscow named after him and a crater on the moon. Let's not forget element 101 that's called Mendeleevian. So to recap, Dmitri Mendeleev, born in Russia, from tough beginnings, he got an education, he got interested in chemistry, and in 1869, he came up with the periodic table. And what's so great about the periodic table? Well, it organizes elements according to similar properties. So, in a glance, just a glance, you get a pretty good idea of what an element's going to be like. Spasiba, Dmitri Mendeleev.
Spasiba, thank you. Or dude, Dimitri. All right. So, what is equal to the number of protons in an atom when you're looking at a, is this gonna, here we go. All right. So what is equal to the number of protons in an atom? What is it? When you're looking at them on the, what here denotes the number of protons?
Wait, the number at the top.
Yeah, what's that called? Do you remember?
Atomic number.
Atomic number, that's right. All right, so 12. All right, so we can look. What are we looking at here? 12 is what? Yeah, okay, 12. All right. And what's the notation of 1 or 2 letters that represent the chemical element? What do we call that, Darcy? Yeah, that's our symbol. Very good. All right. And the chemical name goes right here, right? And then, oops, sorry. And didn't mean to hit that. Hit it early. So the atomic mass is the last thing, and it's expressed in AMU. So remember last week we talked about how tiny the mass of those subatomic particles are. So how tiny the mass of an actual one atom is. So we have to have a new unit because it would be crazy if we did stuff to, what was it? Wasn't one of them
Oh, yeah. It's
negative 31st power for an electron? I mean, come on, we're not doing that. That's crazy. So if you look again, this number is going to be, when you have an element in its kind of natural state, you're going to, or its purest state, I guess, you're going to find it's nearly always about double, right? And why is it about double? Do we remember why the mass is about double? Not the electrons.
Because the protons and the neutrons?
Yes, protons and neutrons. That's where our mass is, right? And then you usually have the same number of neutrons as you have protons, and therefore it should be about double. Not always going to be, because they do have, see, it is a little heavier because they're not exactly the same, right? And then you have electrons to add in too. right? So there you go. All right, and there's our magnesium. All right, so what is each of two or more forms of the same element that contain equal number of protons, but different neutrons? What do we call that? I was just saying, most of the time you have the same amount. What is it when you don't? Eunice, do you know?
A period.
Not a period. Do we know? So this is an isotope. Okay. So when you have, this is like kind of your standard purest form, right? So you like boron here. You're gonna have 5 neutrons and 5 protons. And that's why you have 5 here and then like roughly 10 there, right? But there are times when you have certain elements that are gonna have either one more, or it's usually more neutrons than protons. And those are isotopes. And those are important because that's what we use when we do like radiometric dating, like fossils and things, like on your shirt. It is like, how do we know how old that T-Rex or Velociraptor, whatever that is, right? And that's what we use isotopes for. So because of this, their mass is different, but not their chemical properties. And in particular, some of them are radioactive, and these are the ones that you hear about, like uranium. Those are the radioactive ones, right? So elements are classified as blank, blank, and blank. Do we know what blank, blank, and blank is, Eunice? Do you know?
Simple mass and one.
Yeah, so, well, this time, yeah, that's true. Metals, non-metals, or metalloids. So those are our big classifications. Metals, non-metals, metalloids. And then we have like further classifications within that. So are these things over here metals, non-metals, or metalloids? Do you know?
No.
They are noble gas.
Non-noble.
gas.
They're noble gases that are non-metals, right? Okay. So most of the stuff in the middle here, this is where you find your metals. And then your metalloids kind of come through here. And metalloids are what you find often for semiconductors. So remember when we did electricity?
What is unknown chemical properties? How do we not know? We're in 2024.
So that's interesting. So some of these are ones that you, some of these heaviest ones like this are ones that we've created only in laboratory situations. Like they don't, a lot of these aren't going to exist naturally in nature. So if you think about it, like the elements that exist the most are very often these kind of lighter ones, right? They're really stable. So hydrogen in the universe, think about it, the sun's full of hydrogen and helium, and they're our first 2, right? So these guys down here, a lot of these are just like you throw them in the particle accelerator, that kind of thing, right? And sometimes you'll see, and you will probably see it within your lifetime. There'll be, breaking news, we created a new element, and we will have, but we will have created it for like a nanosecond and then it's gone because it's not stable. But in a particle accelerator, we can do that. Remember, I think, did we talk about it? No, I don't think we did. So there are several particle accelerators. Probably the best known one is in France. It's called CERN, and it's a giant underground loop. It's a tunnel. It's a big ring, and they will accelerate subatomic particles through it super quickly, trying to get them to crash into each other and like basically stick together and make a heavier element. That's what they're doing.
What if they put 2 newtons in that?
Oh, no. So metalloids are the elements with properties that fall between those of metals and non-metals. And like we said, they're the ones that are kind of like through here, right? They're this color, this kind of gold color, right? And those are our ones that make good semiconductors. Metals make good conductors. Non-metals make poor conductors. And metalloids are great for being semiconductors. All right, so here's our element again, our card or whatever, our block on the periodic table. So in the modern periodic table, elements are arranged by increasing what? Think about it. How are they arranged? Darcy?
The atomic weight?
Not mass, atomic
Number.
Increasing number, right? Okay. Each row in the table, what do we call the rows? Okay, Eunice? Okay, a period. All right, and then what do we call the columns?
Group.
Go ahead, Carlos. A group. So what we mean by rows is this way, right?
Horizontal.
Yeah, and what we mean by columns is up and down. How do you remember that columns are up and down and rows are left, right? Do you remember? Do you know a way?
Vertical,
Mhm.
portrait, and landscape.
Yeah, I can do that. So you ever been in a theater and you have a reserved seat
Row 14.
It'll say row something and they're running this way, right? It's not stacks. It's left to right, right? That's how you determine what row you're in, you know? And like my front porch has 2 columns and they run vertically. So if you can remember that columns run vertically, they're often in like in architecture. Yeah, right? And then rows run horizontally. So these are our rows, these are our columns. All right, now let's have a look at this. So properties of elements repeat in a predictable way when atomic numbers are used to arrange them into groups. Atomic mass is the value that depends on the distribution of an element's isotopes in nature and the masses of these isotopes. Okay, so we've been saying that when you add the protons and neutrons together, you get the mass, right? Yes and no. So there are some elements that are going to exist in nature in isotopes pretty frequently. It's not the word I'm looking for. Commonly, there'll be a lot of them. So they consider that when they're putting that number here. It's kind of averaging, not totally. It's a hard thing to, it's a hard concept, and I'm not the one that decided on that. So, but yeah. So you have to consider that they have taken into consideration the quantity of isotopes in nature and which isotopes they are and what the mass of those are. So across the table from left to right, the elements become less metallic and more non-metallic in their properties, right? We got definitely non-metallic over here. All right. So here we have a little table and we're going to look at it chunk by chunk. All right. So first and foremost, we're going to have a look at those. All righty. This little corner here. Now, if you look at it, it's kind of set up a little differently on this table, isn't it? So what I was telling you guys is they can be set up very differently, kind of depending on what you're, this is a little off too, but depending on what you're looking at, right? Depending on how you're categorizing them. So keep that in mind. All right, now right here, these guys here, these are our lanthanides, right? Or we can call them alkali metals. There's 2 names for those. And then these here, what are they on this? What's it say they are over here? Can you see? Alkaline earth metal, right? And here they are also alkaline earth metal. So, oh, not lanthanide. I said lanthanide wrong. I didn't mean to say lanthanide. I meant to say alkaline earth metal. Yeah, alkaline metal. That's just that's what they've termed them, alkaline earth metals. There's going to be a lot of this stuff next year. It gets a little wonky. So then in the middle, we have our transition metals, right? Then we have our, click, do your thing right here, boom. What are these?
Post-transition metals?
Over there, they have them called as post-transition metals, right? That kind of dark blue. And over here, they have them just as metal. So you'll see that there are different ways of categorizing. And then this chunk here, those are our metalloids, right? And then these guys. So if you look here, these guys, they're calling these diatomic nonmetals, but they're often called halogens. And that's what they're called over here, is halogens. So you'll hear them called halogens quite frequently. Then you've got this crew, which is noble gas in both situations. Then you have down here, even more, and then down here, those are lanthanides. Sorry, I read that earlier wrong. Yep. Yep. So you'll see that, you know, it says actinide here, it says lanthanide there. There are multiple ways to describe something. It's kind of like saying Darcy is Christy's daughter, but Darcy is Lewis's sister, but Darcy is Miss Danny's student. Darcy's lots of things, right? But in class, it would matter that Darcy is Miss Danny's student. So that's kind of how I would refer to her, because that is what matters to me. But Lewis wouldn't refer to her as Miss Danny's student. He would refer to her as my sister, right? So it all kind of depends on, you know, how you're needing to describe them. So you have your groups, which are 1A, alkali metals, lithium family. Now you notice there's a family. Okay, we're not going to use a halogen family. Okay, but we're going to start with, hydrogen, sorry. But we're going to start with lithium. And this family, which is our column, all right, we're going to call it by that top element on the chart. Sometimes we will do that. So you can see this one, alkali earth metals, we're going to call it the beryllium family. right? Anybody want to take a guess at what the next one is going to be? Where we're going to go on the chart? Are we going to go here? Are we going to go here? Are we going to go down here? Well, let's see. Boom, we're going over there. Boron family. Then you have carbon family. So then the next one would be? And what's going to be after that? What's this one?
Oxygen.
There you go. Oxygen family. And then fluorine family. Fluoride is not the same as fluorine. And then helium family are noble gases. Right. And then we have, oh, this is weird. We're getting out of a strange order, aren't we? Copper family. Zinc family. Scandium family. See how they're kind of going all over now? Titanium family. Vanadium family. Chromium family. Manganese family. And then look, whoa, what happened there? The iron family got a big old chunk.
They're all 8B.
Uh-huh, yep. And it's iron, cobalt, and nickel, but they all fall into this, yep, 8B situation. So this is kind of where we end up with this sort of thing going on, right? And then we have our periods. So our periods, period 1, okay, contains the least elements than any other with only 2. Hydrogen and helium, right? In that first row, there's only 2. Then you get period 2, elements involve the 2s and 2p orbitals. Okay, think back to lab and candy. You were putting your electrons in various shells, okay? That's what this is. All these guys have the same stuff going on in their 2s and 2p orbitals. And next year, we'll kind of memorize those orbitals. It's a little different. So they include the most biologically essential elements besides hydrogen, carbon, and nitrogen. So look, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So these guys right here, there is a, there's a little acronym we use to help us remember the most biologically important elements, and it's SHNOPS, CHNOPS. So that's carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. SHNOPS. Those are in the, yep.
It's like playing Boggle.
And those are the elements that are in most life forms, the most common in living things. So then our period 3 elements occur in nature, but have at least one stable isotope. So that you all have one stable isotope. All but the noble gas argon are essential to basic geology and biology. Then you get period 4. These are biologically essential, like potassium and calcium, and the first period in the D block with lighter transition metals. So that's when you're starting to deal with like this stuff in here, right? And then you get these guys, and then these guys, and then these guys. So all of the elements in period 7 are radioactive, all of them. Period contains the heaviest element, which occurs naturally on Earth, which is plutonium. That's the heaviest naturally occurring element on Earth. What number is plutonium?
94.
Anybody see it?
Number.
Plutonium would be 78.
You got it, 94.
Right.
Naturally occurring. So what does that tell you about the others past it? They're not fake, but they're, yeah, there you go. There you go. They don't occur naturally. All right. So again, let's have a quick look here. So these guys were known about since antiquity through the Middle Ages. We've known about these elements for a long time. And this makes sense. Carbon, sulfur, right? These are things we see. What's AS? It's arsenic. Arsenic is poisonous. Yeah, so this makes sense that we would know about it, right? Because it's poisonous.
Oh, arsenic.
What's AU?
Gold.
Gold. What's AG? Do you see how they're stacked one on top? Look, copper, silver, gold. Yep. I had a teacher once say that you can remember which one is gold and which one is silver, because if you were walking down the street wearing a silver necklace and somebody grabbed it, not me, I'd be very upset, but somebody grabbed it and ripped it off your neck and ran away, you say, hey, gee. But if they took your gold necklace, you'd say, hey, you, and chase them. So I don't know that that's helpful, but I've never forgotten it. So by the Middle Ages, we knew about all these. All right, this is a lot more stuff. Okay. And then by early to mid 1800s, we'd found all these. Look at this. We still haven't found some of these ones. Look at helium. Helium's like super important. Without it,
It'd be so funny if we haven't found oxygen.
right. So then by 1850, so mid to late 1800s, almost 1900, we found all these. And then 1900 to 1950, we found a lot more. And then if you look right here, 1950 to 1999, post-Manhattan Project. What was the Manhattan Project?
That's the atomic bomb.
Atomic bomb. Synthesis of atomic numbers 98 and above, colliders and bombardment techniques. So this is what we were talking about when I was talking about particle colliders and particle accelerators. And then since 2000, so only in the last quarter century, we have synthesized these. Synthesized meaning created, right? Right. All right.
Artificial?
Yeah, I guess you could call them that. I mean, we created them. So here's a quick, actually, no, this one's long. So I don't want to do this one right now because it's long. I want to do this next thing. Yeah.
No.
Hello.
Go. Okay. So we can play with a, yeah.
I have no phone.
I know most of us don't. So we're going to play right here. All right. We're going to play Hangman.
I'm so good at
And
this, except
you
that
can
I
play
can't.
this one with just me. And later, if you want, you can get home. I'll give you these links and you can play them with, oh, don't strangle each other.
Except for the fact
All
that I
right.
can't
So
spell.
are we ready? Let's see. We will start with Carlos. What are we picking, Carlos? Pick a letter, any letter.
And
Pick an N. Whoop. Ooh, we have an N. All right. And Nico.
A.
A.
That was the same.
Ah. All right, Lewis.
G.
Whoop.
Wait,
They ruin everything.
Darcy.
I want to play it safe, so I'm gonna go with an E for vowels.
It's not.
C.
C, he says.
We already know it.
Carlos.
R.
R. We're catching on.
I know.
B. Lewis.
O.
O.
I'm good by now.
Got it.
Corbin.
And we got Corbin. Yay.
I want to call this the
Let's try the next one. All right. Who's up? Darcy.
S.
S.
Studio.
Uh-oh. Eunice.
Go with A. I.
I.
There.
Ooh.
I just guessed it. J.
J. J.
What'd you call it? J?
What do you think, Nico?
A.
A. All right.
I think it's
Oh, we got an
I
A.
think it's G. G. E.
E.
Yes, Lewis. I think it might be beryllium. Okay.
Darcy.
B.
B. Oh,
No, it's not beryllium.
what's that?
What,
G?
is that an egg?
It's a fat man. We're hanging. Carlos.
Oh, so let's go with P.
E.
Oh,
Ooh.
R.
Wait, it's Nico's turn.
That was me. That was me.
He's thinking.
if the guy gets to the
Toss one out. Anyone. Go for it.
R. T.
T?
T.
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 Uh-oh. Lewis. Oh, no. Never mind. We're dead. What was it? What was it? It didn't tell us. Oh, no. So there's that one. Let me show you. We've also got, hold on. We've got that one. And then we've also got this one.
Yes. Partner.
I printed off.
I'll
the
show you what
front
it looks
roll.
like. What?
Can you send all of these?
Yeah, I will. Mm-hmm. There's this one here.
Periodic table family.
Mm-hmm. And it looks like this. Oh, So where are our halogens? Whose turn was it? Was it, okay, Eunice, where are the halogens? The red ones go to what color on the chart?
Noble gas.
Where are the halogens?
Oh,
Do you remember? They were called something different over here.
Noble, yeah.
They were green. They were called,
Dynamic non-metals.
do you have it? Do you agree?
Yeah.
Okay.
Non-metals.
Put that there. All right, where are the alkaline metals, Carlos? Mhm.
That's the red.
Alkaline metal,
No,
look on the
that's
thing.
red.
It's red, it's red, it's red.
So it's red?
Yeah.
Okay.
100%.
All right, Nico, how about alkaline earth metals?
Alkaline earth metal.
It's the blue.
Blue, right here.
Wait,
It's the blue, trust.
Transition metals, Lewis?
It's orange.
So orange. And noble gases.
Noble gases would be
Purple.
pinky.
Yeah, that
magenta,
kind of hot
purple.
pink one.
Magenta.
All right, so then we check it. Yay! So there's one. Look at that. We got them all right. And then the other game is this one right here.
I can't scan.
This one is a little harder. It's timed. So you have to try and find, for example, erbium, boom, uranium. Where's uranium? Where's uranium? Boom, right? Polonium. So you have to try and find them, and it's kind of fast, right? So this one helps orient you so that you know like where you're looking for stuff. After lab today, this one will be easier.
Time's running.
Yeah,
Time's
right?
ticking.
So after lab, that one will get easier. But anyway, these are fun, right? These are fun, and there's stuff you can do to turn that off. There is stuff you can do to kind of familiarize yourself. Oh, say hi, Emma. Everybody say hello, Emma. Oh, in there. Hello. All right, I'll let Emma go. Bye.